morning, one and all. I welcome all the MPCS second year students to the online classes. The summary of last lecture that we have discussed about vibrations in a bar. In the previous lecture, I have explained when a bar is free at both the ends, how do we calculate the modes of vibrations in a bar. So, the last case of this first part of bars, that is when bar is fixed at the middle. When bar is fixed at the middle, how do we calculate the modes of vibrations in a bar? Just listen carefully. This is the last case in the longitudinal vibrations of a bar. So the bar topic, whole concept is divided into two parts. One is about longitudinal vibrations, second one is about transverse vibrations. So this is the last case in the longitudinal vibrations of a bar. How do we draw a diagram for this case? According to our diagram, according to our case, the bar is fixed at the center. Let us imagine the length of the bar be L. This is x is equal to 0, x is equal to L. I have fixed this bar at its center like this. So when bar is fixed at the center, if it is executing longitudinal vibrations, in such case, how do we calculate frequencies of the bar? This is the scenario. So what are the boundary conditions for this case? Boundary conditions. So boundary conditions. Without boundary conditions, we cannot find out frequencies of the bar. So here we are having two boundary conditions. At x is equal to 0, when x is equal to 0, or at x is equal, right, like this, at x is equal to 0, that is at the first end, this end is a free end, it can vibrate freely, so the displacement is maximum. When in case of free end, displacement of the bar becomes maximum, therefore its first derivative becomes minimum. Already we have used this type of case. This is boundary condition 1. So here I am concentrating on this fixed end, that is this bar is fixed at the center, which is the center means the distance of this point from the first end is equal to how much? L by 2 distance, because the total length of the bar is L. Therefore the center to the first end becomes how much? L by 2. At L by 2, second boundary condition, at x is equal to L by 2 distance, at x is equal to L by 2 distance, the bar is fixed rigidly. Therefore bar is not going to vibrate at this position. The displacement of the bar becomes 0 at this position. So the displacement always represented by y, which equal to 0. This is boundary condition 2. This is boundary condition 1. We have to use these two boundary conditions to calculate frequencies of the bar. Before that, we have to consider the displacement of the bar. That is, since y is equal to a1 sine omega t minus kx plus a2 sine omega t plus kx plus b1 cos omega t minus kx plus b2 cos omega t plus kx. Is that clear? Where a1, a2, b1, b2 are constants. So I want to substitute first boundary condition in this equation. Before that, I have to differentiate this equation 1 with respect to x. To substitute this boundary condition 1, here I am differentiating equation number 1. Differentiate above equation with respect to x. When y is differentiated with respect to x, it becomes dy by dx. So with respect to x, so minus k comes before the equation, minus km, ka1 Sin differentiation cos of omega t minus kx. Coming to the second term, what is the coefficient of x? Again k. So k comes before the equation ka2 sin becomes cos omega t plus kx. Coming to the third term, this one, what is the differentiation of this term? That is minus k comes before the equation, minus into plus becomes minus, but we have to differentiate cos differentiation minus sign, so the minus and minus becomes plus, again we get plus only. So k into, after differentiation of this term, we get k b1, cos becomes sin omega t minus kx. Coming to the last term, so differentiation of this term with respect to x, k comes before the equation, cos differentiation minus sign, plus into minus minus, so final term becomes minus kb2 sin of omega t plus kx. Right, let this is equation number 2. Just to substitute boundary condition 1 in equation 2, you will get a relation between a1 a2 and b1 b2. Simply I am substituting boundary condition 1 in equation 2. So what is boundary condition 1? This one. So when dou y by dou x equal to this one, dou y by dou x equal to 0, we have to put x as 0. So we have to put x as 0. So x values will be disappears from equation 2. So finally equation 2 becomes like this, that is minus ka1 cos omega t plus ka2 cos omega t, third term, plus kb1 sin omega t, and last term minus kb2 sin omega t. Clear? I want to take k cos omega t from as common from the first two terms, k sin omega t as common term from the last two terms. If I take k cos omega t as common from first two terms, what are the terms remained in the bracket? That is minus a1 plus a2. I am writing positive term first, negative term second, that is a2 minus a1. Coming to the last two terms, so from last two terms you can take k sin omega t as common. So what are the terms remaining in the bracket? That is b1 minus b2. So same procedure which we have followed in the previous classes can be repeated here. See, product of two terms equal to 0. To satisfy this equation, one of the term may be equal to 0, either cos k omega t or a2 minus a1. Already we know k never be equal to 0. It is a propagation constant, its value 2 pi by lambda. Cos omega t never be equal to 0. If cos omega t equal to 0, this solution becomes 0. So these two terms never be equal to 0. Therefore, a2 minus a1 must be equal to 0. Similarly, b1 minus b2, this one, b1 minus b2 is also equal to 0. Therefore, finally we get a relation between a1 a2 as a2 is equal to minus plus a1. Similarly, b1 is equal to b2. Let this is equation number 3. Just to substitute equation 3 in equation 1. Simply I am substituting the relation between a1 a2 b1 b2 in equation 1. Substitute equation 3 in equation 1. What is equation 1? That is displacement of the bar at any instant of time. So instead of a2 you can replace as a1, instead of b2 you can replace as b1. So you can take a1 as common from first two terms, b1 as common from the last two terms. So finally our equation 1 becomes sin omega t minus kx plus sin omega t plus kx. This is about the first two terms of the expansion. Coming to the second two terms, from second to two terms you can take b1 as common. So what are the terms remained in the bracket? Cos omega t minus kx, cos omega t plus kx. Clear? Is that clear? Right. So I would let this is equation number 3. Here I am giving number for this equation as 3. Substitute boundary condition 2 in equation 3. Just put x as L by 2 when y is equal to 0. Before going to substitute boundary condition to just solve these values. Simply I am using sin of a minus b, sin of a plus b. Sin of a minus b can be written as sin a cos b minus cos a sin b. Clear? Right. Coming to the sin of a plus b. Sin of a plus b can be expanded as sin a cos b plus cos a sin b. Coming to the second term, that is plus b1 of cos of a minus b. Cos of a minus b can be expanded as cos a cos b plus sin a sin b. Similarly, cos of a plus b can be expanded as cos a cos b minus sin a sin b. Minus sin a. Is that clear? Right. So which term may be cancelled? This is minus cos omega t sin kx. This is plus cos omega t sin kx. These two terms will be cancelled. Similarly, this is minus sin omega t sin kx. This is plus sin omega t sin kx gets cancelled. So next equation will be y is equal to, this is sin omega t cos kx. This is also sin omega t cos kx. Becomes double. That is 2 into, already here we are having a1, 2a1 sin omega t cos kx. Similarly, this is cos omega t cos kx, this is also plus cos omega t cos kx, becomes a double. So along with b1 I am writing 2b1 cos omega t cos kx. Clear? So here I am taking cos kx as common. Y is equal to, simply I am taking cos kx as common. So what are the terms remain in the bracket? 2a1 sin omega t plus 2b1 cos omega t. Let this is equation number 4. To solve the final expression, I am assuming 2a1 as, let 2a1 as a constant a and 2b1 as another constant b. If I consider 2a1 and 2b1 as a and b, so equation 4 becomes, therefore equation 4 becomes cos kx, this is a sin omega t, second term is b cos omega. Now the equation is ready for the final solution. Just substitute boundary condition 2 in equation 6. You can calculate the frequencies of the bar who is executing longitudinal vibrations. So simply I am substituting boundary condition 2 in equation 6. Substitute boundary condition 2 in equation 6. So what is boundary condition 2? That is y is equal to 0. So y equal to 0 when x equal to L by 2. Therefore cos k L by 2 of, these are treated as constants. This is sin omega t, this is cos omega t. Clear? Product of the two terms equal to 0 means one of the term must be equal to 0. So as a and b sin omega t cos omega t never be equal to 0. Therefore cos kl by 2 cos of kl by 2 it must be equal to 0. When cos of the angle equal to 0, when this angle is equal to 2n minus 1 into pi by 2. Right? If you want, you can check where n is equal to, where n is equal to 1, 2, 3 and so on. When n is equal to 1, just put n equal to 1, 2 minus 1 becomes 1. So it becomes pi by 2, kl by 2 equal to 90 degrees, cos of 90 degrees 0. Whatever the values you give for n, finally you will get 0. So this is the solution. So kl 2 gets cancelled. Next I want to calculate k value. So k is equal to 2n minus 1 into pi by l. Right? What is k? K is known as a propagation constant and its value is equal to 2 pi by lambda. 2 pi by lambda is equal to 2n minus 1 of pi by l. Pi gets cancelled. Our aim is to calculate frequencies. So finally we have to convert a wavelength in terms of frequencies. That is, I am writing here, that is, already we did this type of derivation in our previous cases only. 2 by, what is lambda? V is equal to nu lambda, which implies lambda is equal to V by nu. Instead of lambda, we can substitute as V by nu, which is equal to 2n minus 1 into 1 by L. So this nu goes into the numerator and multiplies these two. So 2 nu by V, which is equal to 2 nu by V, which is equal to 2n minus 1 by L. I want to calculate nu value, that is the frequency of the bar, this one. Just keep this value on LHS only. Take 2 by V from LHS to RHS, they will be reversed. So finally we get 2n minus 1 by 2L into V. So the final expression will be 2n minus 1 by 2L into under root of y by rho, where under root of y by rho represents that is velocity of longitudinal vibrations in a bar. So put a nu as nu n. This is the final expression. This is the final expression, and you can represent the modes of vibrations in this bar as when n is equal to 1. This is the final expression. I am giving number for this expression as some 7. How do we find the modes of vibrations? Modes of vibrations are nothing but possible frequencies executed by the bar. Clear? So when n is equal to 1, first case, n is equal to 1. When n equal to 1, 2 minus 1, 1 by 2L. So nu 1 is equal to 1 by 2L under root of y by rho. This is the first possible frequency in the bar. That is also known as first harmonic. How do we represent this in a diagram? So at middle always produces node only. So either side of the bar is executing, bar is vibrating freely. That is why the displacement of the bar at these positions will be maximum. That is why we get antinode here. The point is known as antinode. So at a fixed point, it's not possible to vibrate the bar. So we get a node here. So finally we represent the diagram is like this. At the center we get a node. At the two ends we get antinodes. This is the way to represent the diagram for this frequency. Similarly, when n is equal to 2, when n is equal to 2, n equal to 2 means 2 2s are 4, 4 minus 1, 3. So it becomes third harmonic, 3 by 2L under root of y by rho. So this is third harmonic. In case of when bar is fixed at the center, always we get odd harmonics. This is third harmonic. So how do we represent this in a diagram? Always we get antinode. This is the way to represent the diagram. Antinode at the free ends, right? So this is the third harmonic. When n is equal to 3, we get a fifth harmonic like that. That means when bar is fixed at the center, always we get odd harmonics only, 1, 3, 5 like that. So this is about when bar is fixed at the center, and if it is vibrated, how do we calculate the frequencies of the bar? Clear? I have finished the first part of bars. We are having second part of bars. If I finish the second part of the bar, that means our first unit will be successfully over. Clear? And one more thing, the last part of this first unit I will send individual videos which I have already taught in our previous your seniors. I will send these videos to Kirti so that she can send those videos into your personal group. Just watch the videos. Already I have sent notes. So just go through the notes and watch the videos. You can understand the last part of the bars. And remember, in the last part, that is, what is the last part of the bar? That is transverse vibrations in a bar. I have finished longitudinal vibrations in a bar. The last part of this unit is transverse vibrations in a bar. In that unit, we have to calculate the general equation for transverse vibrations in a bar. And after that, one important topic is, that is a long question. Transverse vibrations in a bar itself a long question, okay. One important short question is there, that is tuning fork. So tuning fork is a regular short question in this bars concept. So just go through the notes and watch the video. Today itself I will send the old videos to Kirti, so that she can send the videos into your personal group. And remember, don't read only 2 units, because nowadays COVID paper is they are giving 50% syllabus. So most of the students are preparing only 2 units out of 4 units. You are preparing 2 units, and my suggestion is prepare 3 units. If you prepare 3 units, that will be very helpful in the annual examination. Clear? Right. So here I am going to start the 3rd unit of your semester 4, that is a diffraction. Right? Diffraction. If I complete the diffraction unit, that means your syllabus will be over. Clear? Right. So due to time fact only, because exams are very nearer, the working days are reduced. That is why I am sending the old videos to your group. So due to time fact only I am doing this. And if you have any doubt, please call me and clarify your doubts regarding the syllabus. Right? So here I am going to start the 3rd unit of your semester 4. And one more thing, if we are having nearly 3 to 4 classes, that is almost, this is the Wednesday, Thursday, Friday, Saturday, nearly 3 classes are there. After 3 classes, if any topic is left to complete, I will send the old videos to your personal group, old videos to Kirti, so that she can send the videos into your personal group, so that our syllabus will be over. Right? And today itself I will send the 3rd unit notes also, that is diffraction notes also. Clear? Right. What is the first unit name? Waves. Second unit is interference. 3rd unit is diffraction, that I am going to start here. 4th unit is polarization. Already I have finished. So out of 4 units, I have finished 3 units successfully. Here I am going to start the 3rd unit of your syllabus. Listen carefully. What is your 3rd unit name? That is diffraction. What is diffraction? I think some of you are familiar with the diffraction topic, because already have learned about diffraction at your intermediate level only. Diffraction, it is one of the phenomena of the light. When light is passing through an obstacle whose width is comparable with the wavelength of light, then light bends at the edges of the obstacle. The bending of the light at the edges of the obstacle is known as what? Diffraction. So we are going to discuss the diffraction phenomena, how many diffractions are there. So how do we explain those types of diffractions, right? Every types of diffractions are very important, long questions. Just listen carefully. So our topic name is diffraction. Unit 3, that is diffraction. How do we explain about diffraction? When light is passing through an obstacle whose length or whose width is, whose size is the comparable with the wavelength of light, then light bends at the obstacle. The phenomena of bending of the light at the obstacle is known as diffraction. This is the light, and it is passing over this obstacle. I have placed an obstacle whose size, imagine the size of this obstacle is comparable with the wavelength of light. What is that? What does this term means? Always the size, wavelength is measured in angstroms, which is very small value. If the size of the obstacle is almost equal to wavelength of light, then light suffers diffraction. Clear? Right. And diffraction, this phenomena is divided into 2 parts. Types of diffractions. And one of the important question in this unit, short question, types of diffraction. The first type of diffraction is known as Fraunhofer diffraction. Fraunhofer diffraction. Second type of diffraction is Fresnel's diffraction. Fresnel's diffraction. What is Fraunhofer diffraction? The name itself is specifying. You can remember easily by concentrating on this term. Hofer. Fraunhofer. Far means just use this term. Just concentrate on this term so that it is easy to remember the definition. Here I am defining the definition of diffraction. To get the diffraction pattern, we need to have an obstacle. We need to have a source of light. That this is source of light. We need to have a screen, right? So that we get a diffraction pattern on the screen. So to get the diffraction pattern, what are the minimum arrangement we should make? That is source, obstacle, screen. With respect to the distance between the source to the obstacle and obstacle to the screen, this diffraction is divided into two parts, two types. What is Fraunhofer diffraction? First point, when the source, that is S, and screen are placed at infinite distance from the obstacle, then the diffraction is known as, diffraction at the obstacle is known as Fraunhofer diffraction. This is the definition of Fraunhofer diffraction. How do we define? Hofer, that is why in the beginning of the topic only I am saying, that is just concentrate on this term. When the source and screen are placed at infinite distance from the obstacle, then the diffraction at the obstacle is known as what? Fraunhofer diffraction. Coming to Fresnel's diffraction, opposite to Fraunhofer. When source and screen are placed at a minimum distance or finite distance. This is a very important term. Finite distance from the obstacle. Corresponding diffraction at the obstacle is known as what? Fresnel's diffraction. To get the Fresnel's diffraction, we need to place that source and screen are finite distance. The distances should be measurable. Clear? This is about the first point of Fresnel's diffraction and Fraunhofer diffraction. During Fraunhofer diffraction, lenses are used. In Fraunhofer diffraction. Coming to Fresnel's diffraction, no lenses are used. To get the diffraction pattern by using Fresnel diffraction, no lenses are required. No lenses are used. Here I am explaining the differences between the Fraunhofer diffraction and Fresnel's diffraction. And one more point, the light which is incidenting on the obstacle is plane wavefront. The shape of the incident wavefront on the obstacle is plane wavefront, because already the light travelled through longer distances in case of Fraunhofer diffraction. When light travels through longer distances, it becomes plane wavefront. Clear? Coming to Fresnel's diffraction. In case of Fresnel's diffraction, source and screen are placed at finite distance. That is why the shape of the incident wavefront on the obstacle may be incident wavefront on obstacle may be spherical or cylindrical. This is about one more point. And one more thing, this diffraction can be viewed in any direction, any direction of the incident light, any direction. You can observe this Fraunhofer diffraction in any by viewing through any direction. If you place here, you can observe this diffraction. There is no restriction to observe the Fraunhofer diffraction. But in case of Fresnel's diffraction, we have to place the telescope along the direction of the incident light. These are the differences between the Fraunhofer diffraction, and remember, this is a very, very important question for 4 marks. Nowadays they are giving this question for 10 marks, regular question. Just go through the notes. Tomorrow I will continue this topic. Until then, bye bye.